Welcome to this explainer. Okay, today we are going on an absolutely mind-bending journey. We're looking at how we're actively predicting the future capabilities of science. And I mean scaling all the way from manipulating the absolute smallest subatomic particles in the universe, right up to drastically altering the DNA of our global food supply. It's going to be wild.
So, think about this for a second. What happens when our scientific capabilities actually outpace our imagination? It's a pretty profound thought, right? Because as we stand on this extreme edge of scientific power, successfully predicting and unlocking these new capabilities creates a really urgent need. We have to anticipate their consequences, and we have to do it now.
Here's our roadmap for today. We're going to start by predicting scientific capabilities, then look at revolutionizing global agriculture, pushing particle physics, the next great colliders, and finally, navigating scientific ethics.
So, Part 1. Predicting scientific capabilities, from micro to macro.
This right here is the absolute core theme of our journey today. The future frontier really demands that we balance unprecedented predictive power with profound ethical responsibility. You see, big science isn't just about abstract equations on a chalkboard anymore. It fundamentally transforms our global society. As our predictive power in physics and biology grows at this exponential rate, we have to simultaneously build the frameworks needed to govern it all.
Moving on to Part 2, Revolutionizing Global Agriculture, Radioisotopes in Action.
You know, we so often think of nuclear science as something totally confined to energy grids or weapons. But the truth is, we can actually deploy highly targeted radiation to solve massive biological problems. Take the sterile insect technique, or SIT. First proposed way back in 1955, it's essentially pest birth control. By releasing huge numbers of radiation-sterilized male insects into the wild, they go out and compete with the regular males. The result? The eggs produced are completely infertile. This highly specific technique has successfully wiped out massive agricultural threats like the Mediterranean fruit fly and the screwworm, and it does it without dumping toxic pesticides all over the environment. Talk about a game changer.
And honestly, our predictive capabilities don't just stop at pest control. We are actively tracking exactly how plants absorb fertilizers using specific isotopes, like P32 and N15, to maximize crop yield and stop nasty chemical runoff. We've also been using X-rays since the 1930s to induce mutations for disease-resistant crops. And get this? By gently and completely safely exposing food to up to 10 kilograms of gamma irradiation, we can kill off harmful bacteria that massively extends the shelf life of the food that eventually reaches your table.
All right, let's zoom back in for Part 3, Pushing Particle Physics, the Quantum Frontier.
So, pivoting away from the macroscopic world of agriculture, let's look at the absolute cutting-edge quantum frontier. We really need to review CERN's massive achievements from just last year in 2025. I mean, it literally reads like science fiction, but this is our reality now. They demonstrated the very first antimatter quantum bit. They also successfully converted lead nuclei into gold, literally realizing the ancient dream of alchemy. No way, right? Plus, they collided oxygen and neon ions for the first time, and the Large Hadron Collider delivered a record amount of data. All of this just proves that the incredible future of particle physics we've been predicting, yeah, it's already arriving.
Which brings us to Part 4, the next great colliders, behemoths of discovery.
Now, the current Large Hadron Collider is incredible for sure, and it's getting a high luminosity upgrade soon. But predicting physics into the 2040s requires some true scientific behemoths. 15 billion Swiss francs. Let that sink in. That is the staggering estimated cost for just the first stage of the proposed Future Circular Collider, or FCC.
To put that into perspective, the FCC is a proposed 91-kilometer machine. It is massive. Stage 1 is an electron-positron collider, acting as a Higgs factory. Its whole job is to study the simplest, yet kind of most perplexing particle we know. But that first stage really just paves the way for Stage 2, a proton-proton collider operating at 100 tera-electron volts. For some context here, that is nearly 7 times more powerful than our current world record. That kind of juice is going to allow us to predict and discover entirely unknown realms of new physics.
But hey, the FCC isn't the only predictive model we're looking at. Consider the muon collider timeline. Now, colliding muons instead of protons offers some really unique advantages, but it is incredibly complex. Why? Because muons are highly unstable. So getting a machine like this operational by the 2040s requires an immense, immediate leap in research and development right now, especially ahead of the upcoming European strategy for particle physics updates.
And when you think about the massive jump in infrastructure required to go from a 3 TeV
to a 10 TeV muon collider, the engineering required is absolutely staggering. I mean, imagine trying to perfectly corral and accelerate a chaotic swarm of particles to nearly the speed of light, all before they naturally vanish in just a fraction of a second. That is the wild reality of designing these rapid cycling synchrotrons.
Finally, Part 5. Navigating Scientific Ethics, Power and Responsibility.
It's super easy to get lost in the awe of these massive machines. I know I do. But we really must pivot to the absolute necessity of rigorous ethical frameworks. As a 2024 University of Tartu paper points out, we have to weigh these incredible scientific innovations directly against their immediate risks. For instance, AI and big data revolutionize research, sure, but they also risk massive privacy loss. CRISPR opens incredible doors to genetic editing, but it brings the very real risk of unintended biohacking consequences. Bottom line, our ability to predict and manipulate the world simply cannot outpace our safety oversight or lead to inequitable stewardship.
I want to share a really powerful quote from the literature that hits the nail on the head here. Ethics is the foundation of scientific inquiry, ensuring that research not only advances knowledge, but also serves humanity responsibly and equitably. I love that, because as our science scales up, from mutating crops to colliding particles at unimaginable speeds, so does our duty to maintain public trust, promote transparency, and, crucially, protect vulnerable populations.
So this leaves us with one final, really urgent question to think about. As we unlock the universe's ultimate secrets, how will we ensure that this knowledge is used to benefit all of humanity? Science is predicting and building the future faster than ever before. Understanding its capabilities and its risks, well, that's a responsibility we all share. Thank you so much for joining me for this explainer today. Keep asking questions, keep learning, and I'll catch you next time.